Hello everyone, and welcome to my SB2 channel. Today we're going to be looking at the atomic structure. I have subatomic particles for you, atomic symbol, a little bit on the isotopes, how we can do the calculation for the atomic weight, and then we also have a couple of practice that we can do together at the end. Okay, so starting by subatomic particles. For all the atoms on the periodic table, we're going to have these three particles, starting by protons, and these are the ones that are positively charged. And if you look at their masses, they're going to have about 1 AMU, and this AMU is just a fancy unit for grams per mole. Okay, and then if you think about where you can find them, we can find them in the nucleus. Now, for the neutrons, they are neutral, right? So we don't have any charges. They're going to be a little bit heavier than the protons, but we still can approximate them to about 1 AMU. And just like your protons, we can find them in the nucleus. So both of these heavy particles, the protons and the neutrons, we can always find them in the nucleus of the atoms. Then we have electrons that are negatively charged, and they're going to be a lot lighter than the other two particles. You can approximate their masses to be about 0 AMU, like negligible, pretty much, right? And we're not going to have them in the nucleus. They're actually going to be outside of the nucleus. They're going to be orbiting around the nucleus. Now, for all of these atoms on the periodic table, we're going to have a kind of systematic way to present them. So we have a symbol, we call them the atomic symbol, right? For each of these atoms, we're going to have the mass number, which is the top left number, and that is presenting the sum of your protons and your neutrons. And that must be always an integer number, right? Then we have another number, which is known as atomic number, which is on the bottom left of your atomic symbol, and that is presenting the number of protons. So this is actually going to specify the elements. So that means if I have two species that they have different number of protons, we're going to have different elements, right? Okay, now on this page, we're going to be looking at the isotopes, okay? If you look at the carbon that I have here, there are 4 different isotopes of carbon, meaning that they all have the same number of protons, which is going to be the 6, right? Because these are all carbon. And I don't have any charges for them, so the number of electrons are also going to be equal to your protons, right? Now, depending on the mass number, for carbon 11, the mass number is 11. That means I have 11 minus 6, which is going to be 5 neutrons, right? You can do the same sort of calculation for the rest of them. So these isotopes are going to have the same number of protons because they are the same element, but because we have different number of neutrons, their mass numbers must be different. Now, if you look at the carbon on the table, it says the atomic weight for carbon is 12.011 AMU. That means this value here, this atomic weight, is different than all of these numbers that we have for the isotopes, right? So that means we cannot find mass number on the table. Rather than that, we're going to have the atomic weight. So let's talk about what are the atomic weights and how we can do the calculation for them. So there are going to be a few steps here. Step number 1 is identifying the percentage for each isotope and their masses. And then we're going to multiply the mass by the percent. And then we're going to sum them up for all of the isotopes that are given to us. This is going to give us the atomic, or let's say the average atomic mass, which is also known as the atomic weight. Okay, so now let's take a look at a couple of practice. Okay, so looking at the first practice, the question is how many protons, neutrons, and electrons are in an atom of strontium 90. So if we look at the periodic table, we can figure out the atomic number, which is 38. That means we have 38 protons, right? And we know that we're not going to have any charges, so we're expecting to get the same number of electrons, which is 38. The mass number is given as 90, so I'm going to go by 90 minus 38, and that will be 52, which is the number of our neutrons here. Okay. Now, here's the second practice. The question is, we have two isotopes for chlorine. As you can see, you've got the mass as well as the percent for each of them. And then the question is, calculate the atomic weight of chlorine. Okay, so I'm going to start by multiplying the mass and the percent for each isotope, and then you sum them, right? Which is going to be 35.453, and that is going to be 35.45 AMU as our final answer. Thanks so much for watching. If you found this video helpful, don't forget to give it a thumbs up and share it with someone who might find it useful. If you're enjoying the content and want to keep learning with me, hit that subscribe button and turn on the notification bell so you don't miss any of our future videos. I would love to hear from you. Drop a comment below if you have any questions or topics that you'd like me to cover in the next video. Your support means the world to me and it helps this channel grow. Thanks again, and I'll see you in the next one. Bye bye for now.